Hi everybody, welcome to topic number 33, solving quadratic functions and their graphs. Let's remember that a quadratic function is a function that can be written in the form of ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. A quadratic function is often called a parabola. That is the U-shaped graph that it makes. So if you've ever seen a U-shape in a graph, that is called a parabola, and it comes when the function has its highest degree of 2, making it a quadratic. Some properties about it. If the a value is bigger than 0, so if the a value is positive, then it will open upward. If the a value is less than 0, so if the a value is negative, then it'll open downward. So if it opens upward, it makes a U shape. If it opens downward, it makes an upside down U shape. The vertex of the parabola is the lowest point or the highest point depending on which way the parabola opens. So if it opens upward, then this here is the lowest point, which is the vertex, and we often call that the minimum. So the minimum value is the lowest point on a vertex that opens upward. If it opens downward, it makes the highest point, which is called the maximum. The axis of symmetry is a vertical line that passes through the vertex. So think of the axis of symmetry as a place where we can fold over on the vertex, and it would be the same on both sides. Our job is to be able to graph these by recognizing things such as how to find the vertex, how to graph the axis of symmetry, and how to find its intercepts. So some key things to find the vertex when we have it in this ax squared plus bx plus c form. For the vertex, if I want to find the x-coordinate, we have a formula that will help us find it. And that formula is we'll take the opposite of the b term and divide it by 2a. If I want to find the y-coordinate of a vertex, I will find the function at that value. So whatever I get here, I will find the function there and plug it into my ax squared plus bx plus c, and then that will end up being my vertex. My axis of symmetry will always go through my x-coordinate, so the way I find the vertex, this will also end up being the axis of symmetry. For the intercepts, again, we have an x and a y-intercept. The y-intercept is always equal to the constant term. So whatever the term value here is for c, that will end up being my constant. For the x-intercept, we would have to take the entire function and we would set it equal to 0. And then we would go through and either try to factor it or use the quadratic formula or completing the square to find its values. Let's take a look at this example and see if we can do these. So we have the function x squared minus 3. So in order to find the vertex, the first thing I'm going to do is I'm going to find the x-coordinate. I'm going to take the opposite of b over 2a. So if you look here, this is the x squared, so this will end up being the a. And this is just the constant, it's negative 3. So I have a equaling 1, because there's no number in front, and I have c equaling negative 3. I don't have a b term, so we have b equal to 0. So the opposite of 0 is simply 0. 2 times 1, well, this is 0 over 2, which is 0. So the x-coordinate for the vertex is 0. That also means the axis of symmetry is equal to 0. We always set it up like an equation, so we say x equals 0 for the axis of symmetry. If I want to find the y-coordinate, all I'm going to do is I'm going to take the function and I'm going to solve for 0. So I'm going to take all of the x's and replace them with 0. So 0 squared equals 0. So f of 0 is 0 minus 3, which is negative 3. So that tells me the vertex is at 0, negative 3, which is we'll call right there. Now for the intercepts, the y-intercept is equal to the constant value, which in this case is negative 3. So in this case, the vertex ends up being the y-intercept. For the x-intercept, we're going to take the entire function and we're going to set it equal to 0. And my job is to then solve for x. In this case, we can use the square root property. We can add 3 to both sides. we get x squared is equal to 3. And then we square root, and we get x is equal to plus or minus square root of 3. And you'll remember from the last video that when we square root now, we want to have this plus or minus. So my x-intercept is at square root of 3 and at negative square root of 3. Square root of 3 happens to be somewhere between 1 and 2, so we'll put our dots right here. And then we can connect our graph and graph these. And as you notice, the graph will open upwards. And we remember that is true. When A is positive, it opens upwards. So that holds true in this graph here. Let's try again with this function. So again, for the x-coordinate of the vertex, we're going to do negative b over 2 times a. So here's a, here's b, here's c. So b is negative 4, so I want the opposite of negative 4, so it's positive 4 over 2 times a, which is just 1. So this is 4 divided by 2, so the x-coordinate of the vertex is 2. It also means the axis of symmetry is going to be at x equals 2. For the y-coordinate, we'll find f of 2. So we'll do 2 squared minus 4 times 2 minus 12. 2 squared is 4. Negative 4 times 2 is negative 8 minus 12. That ends up being negative 16. So the y-coordinate is negative 16. So we'll go to 2, and negative 16 in this case goes off the chart, so we'll put it way down here, and we'll call this point 2, negative 16. And as a reminder, this will end up being the minimum value. Why will this be the minimum value? Because again here, a is equal to 1, so we expect it to open upward going this way. For the intercepts, for the y-intercept, we've got 1 at negative 12. So we'll go to 0, negative 12, and graph this point. Again, this goes off this graph, so we'll call this point about right here, 0, negative 12. For the x-intercepts, we'll take the entire function and we'll set it equal to 0. So x squared minus 4x minus 12 equals 0. And we'll see if we can solve this. In this case, this is factorable. Can we find something that multiplies the negative 12 and adds negative 4? It would be negative 6 and positive 2. We take each one of these and set them equal to 0. And we find our x-intercepts to be at 6 and negative 2. So I go back up here. Here's the one at negative 2. 1, 2, 3, 4, 5. And here's the one at 6. Also, and this might become helpful in my math lab when you do it. Because this is at 0 and this is 2 and this is symmetric, we know that since this is 2 to the left, we also have a point 2 to the right that's exactly the same. So we will have a point at 4, negative 12. And I can say that because, again, we have an axis of symmetry that kind of cuts this graph in half. So if I have a point that's 2 to the left here, then I also have to have a point that's 2 to the right going the same way. So my graph will end up looking like this parabola, opening upward. And again, it opens upward because a is equal to 1, and this value, the vertex, ends up being the minimum in this case. If the graph of a quadratic function is written in a form that looks like this, f of x equals a times x minus h squared plus k, we can easily find the vertex h and k and the equation of the axis of symmetry at x equals h. So we end up calling this form later on, when you get to college algebra, vertex form, which is similar to the it's still a quadratic, but we look at the vertex in this case. Again, a is going to tell us if it opens up or down. As long as a is positive, it's going to open going up, and as long as a is negative, it will open going down, just like we've seen before. But in this case, the vertex is h and k. Now, one thing I always like to point out, for a vertex being h and k, we always want to do the opposite of h, because if we notice here, h is negative. but here h is positive. So whatever we see here, we're going to take the opposite and call that our vertex. So if you see x minus 5 here, that x coordinate is really a positive 5. Whereas if you see x plus 5, that's really negative 5, because the only way this becomes a positive is if there's two negatives. The k we take as whatever it is. So whatever, if k is positive, then k here will be positive. If k is negative, then k here will be negative as well. Let's show you what we mean here. So in this case, when we ask us for the vertex, we don't really need to go through much. This is our h, and this is our k. Here our h looks negative, so our vertex is at 3, 1. So 1, 2, 3, and 1 here. The axis of symmetry will be at x equals 3. Now, we can expand this out if we want to find the intercepts. So in order to do this, let's go through and now multiply this out. So this is x minus 3 squared, which is just x minus 3 times x minus 3 plus 1. This becomes x squared minus 3x minus 3x plus 9 plus 1. So, sorry, I have that. I have x squared minus 6x, and then these combine plus 10. So now it's back into the form we saw earlier, where we have a equaling 1, b equaling negative 6, and c equaling 10. And remember, for the y-intercept, it's always the constant. So in this case, the y-intercept is equal to 10. So I would come up here, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'd be somewhere up here. Now, we also see a is equal to 1, so it's going to open upward. And since it's going to open upward, we know it's not going to hit any of this x-axis here. So for the x-intercepts, we don't have any. Again, it's going to open upward, and this ends up being the minimum point, so there's no way it hits any x-intercepts. Again, because we have this axis of symmetry, if we wanted to find a second point, we could. This here is 3, 1, and we know this is 0, 10. So from 3 to 0, we had to go 3 to the left. So if I take this 3 to the right, I will find the point 6, 10 also to be on this graph. And so my graph will end up looking like this. Okay, but again, that vertex form helps us find the vertex right away instead of having to go through and use the formula. Same thing here, just notice that we don't have anything added to it. So it's really like saying plus 0. Here's the h and here's the k. Now here it ends up being a plus 4. So when I go to write it in my vertex, we write it as a negative 4. So my vertex here will be negative 4, 0. Which also means my axis of symmetry is at negative 4. I should be able to cut it right down the middle here. Expanding this out, we have x plus 4 times x plus 4. So we have x squared plus 8x plus 16. So I know that then my y-intercept has got to be at 16. So my y-intercept is way up here at 0, 16. And because we know this is negative 4, 0, that means we also have a point 4 the other way. So from negative 4 to 0, that's 4 this way. So I'm going to go 4 this way, and I know I've got a point at negative 8 and 16. The only x, this acts as the x-intercept, so my x-intercept in this case is simply negative 4, 0, and because there's nothing here, we could see a is equal to 1. We know that it is going to open upward. So again, we use the vertex formula basically if it has already gone through and been factored. A ball is tossed upward from the ground. Its height in feet above the ground after t seconds is given by the function h of t equals negative 16t squared plus 24t. Find the maximum height of the ball and the number of seconds it took to reach the ball to reach the maximum height. So if you think about it, what it's saying is we have some sort of parabola and we threw it. And eventually the ball reached the maximum height. And then it went through and it hit the ground. So it wants to know how long did it take to hit the maximum, and how high was it when it hit the maximum. So it's really, we're asking for the vertex here. The x-coordinate will end up being the time that it took, and the y will end up being its highest height. So we could do this the same way we've done the vertex before. We'll use negative b over 2a. So in this case, we have 24. So negative 24 over 2 times a, which is negative 16. So negative 24 over negative 32, which gives me 3/4, or 0.75. So they're saying it took 3/4 of a second to reach its highest point. And if I want to figure out what that would be, I would go through and I would plug 0.75 into here. So I would go 0.75 squared plus 24 times 0.75, sorry. And we would solve. And we would get, if you were to solve it, we would get h of 75 to equal 9. So it's telling me the vertex is 0.75 and 9. The maximum height of the ball and the number of seconds it took to reach, the time is the x-coordinate. So it took 0.75 seconds to reach a height of 9 when it goes through and it reaches up. 9 feet in this case. So we can use that vertex formula to be able to go through and solve this.